So I'll try to be the balanced view, or the even more balanced view. So I'm not involved in defending any of those. So,
but neither was.
So just going back on what pricing pressure screens are, and I guess Joe would have done it much better than me. But so if you have here the simple formula, upward pricing pressure, so the basic version that was initially proposed by Joe and Carl Shapiro is this small formula here, where what you care about is so the margin on the merging products, the diversion ratios between the products from the different parties, and possibly some cost efficiencies that you are adding up to the model. So there have been several variants proposed to that initial version, but they all involve the same ingredients, so prices, marginal costs, and diversion ratios. And so that's, in a sense, the very positive aspect of this UPP test, that they are very simple screens that can be carried out with limited information, and that deal with product differentiation in a better way than just using market share can do. One of the other positives of UPP is that contrary to proper definition of delimitation of market definition through the SNP test, for example, parties only need information on their products to carry out the UPP test. You only need to know the costs, so costs and prices on the merging parties' products and diversion ratios between those products. You don't need any additional information that you would need to do the SNP test, which is having margins on all products, so including your competitors' products, so knowing the prices might be possible, but usually knowing the costs, your rivals' cost might not be easy. And you don't need to know the diversion ratios between your own products and your competitors' products. You only need information on the parties' products. So it's, in the end, a screen that can easily be implemented as well by parties to the merger. And that's true, or that's true for all the variants that can be looked at. So the gross upward pricing pressure index, which is simply the more or less the first part of the UPP, where you don't introduce cost efficiencies, and as Joe explained, so that term just corresponds to your opportunity cost, so what you're losing from internalizing the effect, the impact of the merger. And if you know something about pass-through rate, this guppy value can be multiplied by your pass-through to get some estimation of what the price increase could be. IPR, again, is very similar to that. You use the same kind of information. I've only put formulas here for the symmetric cases, but it's just slightly more complicated in the asymmetric cases, but still using the same ingredients, price, costs, and diversion ratios, only for the products of the merging parties. There's one issue there of which demand, the additional bit is really making some assumptions on the form, of the functional form of the demands, and that really affects, so as Joe explained, that affects the pass-through, and in a sense here will really affect the price increase that you anticipate using IPR, depending on whether you assume a log linear or isoelastic demands, or whether you use linear demands. So the factor can be pretty important in some of the mergers. So why are price pressure screens useful? So I'm not going here to compare with merger simulation and look at what are the difficulties with merger simulation, but rather look at where we are starting from. So what we are normally using are market shares, or market shares-based tests. So these market shares can be very informative, but they can be very informative as long as you properly define your markets. And that's the extremely difficult exercise. So Cayuve is somewhere here at that quote a few months ago. that in the end the SNP tests or delineating markets using the SNP test as should be the normal quantitative method is really not more than a thought experiment, and that you rarely see the SNP test carried out properly in practice. So if you really were to do the SNP test properly, so you need a lot of information on the market, so you need a lot of information on the parties' products, but also on the competitors' product, and you've more or less done a merger simulation in disguise when you simply carry out your SNP test. So if you've already done your merger simulation, there's no point in going back to using that to define markets and use market share to estimate the effects of the merger. You've already done most of the exercise. So if we are not sure how we define markets, we are not sure that our market shares are really meaningful in terms of being used as predicting the potential impact of the merger. And that's where price pressure screens play a role, is that they deal with that. They partly deal with product differentiation in a way that market shares or HHI can't do. They require, as I already said, limited information, and as Mark will probably show in his presentation, they are no more imperfect than market share based screens, or at least, so if Mark spends time on that part of the paper. So, but obviously there are difficulties with the price pressure screens. I won't go into talking about how to estimate the price cost margin. There's just one thing, is that we are looking at the marginal effects of the merger, so we should care usually about marginal cost, and that's something that might be difficult. To estimate. So let me just focus on diversion ratios. And here the issue is, how can we compute diversion ratios in a simple way so that we can use our UPP or variants of price pressure screens as a simple screen that can be used in a very short time limit, so in phase 1 cases, without carrying out full econometric estimations of the parameters. So one way that we could do that has been suggested is to use pre-merger market shares to kind of estimate diversion ratios. But so here I don't really see the points. So UPP or those variants are supposed to be tests that help you not using market shares and use information on substitution between products or closeness of substitution in a better way. So if you just go back to market shares, you're completely lost all the benefits of these price pressure screens. And so that I've borrowed from a paper that Chris wrote a few years ago based on cases on merger cases at the CC. You've here plots of, in the Morrison-Summerfield merger of the diversion ratios that were computed using consumer surveys, so at the doors of the supermarket, so that would be on the vertical axis. And on the horizontal one, you have the diversion ratios that would be implied by market shares. And you can see, so I've just put one for a small, so look at the red part here. So for one diversion ratio implied by pre-merger market shares, so you can have several examples of in those 50 or something supermarkets that were there, where the true, or at least the estimated diversion ratios from the survey differ substantially from, or can differ substantially from one store to another, even when they would generate the same diversion ratio if you simply use market shares. So one other way, and I'll borrow again from Chris's work here, is that you could use past mergers, especially if you're using that for mergers in the retail industry. You could try to predict diversion ratios from store characteristics, looking at past data, and then in new cases, use that relationship between product or store characteristics and diversion ratios to infer directly diversion ratios quite easily in your new merger cases, simply using that link and the product or store characteristics in your new case. But there again, that's quite, that's doing quite some strong mistakes in what your estimated or predicted diversion ratio could be. Here again, you have one of the, so I think that was HMV Otakars merger, and you have the surveyed diversion ratio. So again, computed from consumer surveys, and the predicted diversion ratio. So you run an econometric estimation of your diversion ratio based on store characteristics, and you try to implement that. As you can see, for the same predicted diversion ratio, so here about 15%, you can get true or best estimated diversion ratios that can vary from close to 0 to about 30%. So big variance here. So another example, but let me just drop that. When in the end, precision is still quite important, especially if you want to use that in IPR simulation. So I'm not going to go through all this formula here, but for the same, for what would be relatively small margins of error in the measurement of margins and or diversion ratios. So remember in the example I had before, for one case you could have true diversion ratios for the same predicted value that were going from close to 0 to about 30%. I'm only here talking of error of margins of about 5 points. So just that can already give you results that can vary from price increases anticipated through IPR of less than 2% using linear demands for up to 17 using isoelastic. So even if you use the same values, so you can more or less multiply by 3 your anticipated price effect just by having small mistakes or relatively small mistakes on your predicted margins or diversion ratios. So third way of estimating diversion ratios is estimate a full demand model to precisely compute elasticities and use those estimated elasticities to compute your diversion ratios. So this will potentially generate quite precise estimations of diversion ratios, but again, if you've done that, you've already almost done, or you've done most of the hard work for your merger simulation, so why stop there and just revert to a simple UPP test when you've already done most of the work for your merger simulation. And as Joe explained, you've already put a lot of constraints on what your demand model will be. So if there is something wrong there, it will be wrong in your merger simulation, but it will anyway be wrong in your UPP estimations. So more practical ways, and I'll go quite quickly there because the 2 presentations in the second part will probably focus on practical implementation of the test. But what can you use to estimate diversion ratios without estimating precisely the, for example, from price data, those diversion ratios? Where one is often used is switching patterns. So you look at past consumptions and current consumptions by consumers, and you look at how consumers have switched from one product to the other over time. Well, this might give you some information, but very often you don't know why consumer changed. So you might not have observed any changes in prices and still observe consumer switching, when what you care about is really how consumers react to price changes and how they will switch from one product to the other. And when you have price changes, it's rarely the case that you have a price change on one product only. So you will have multiple price changes, and so the diversion ratio, the switching that you observe is a combination of those diversion ratios. And so going back to the true or the clean diversion ratio on 2 products will be quite difficult. So you can use evidence from the firms themselves, so they often care about consumer switching or diversion ratios, because that's really, they want to know, they tend to like to know who are their closest competitors and who they should monitor to when they set their prices or when they change their products, or when they reposition products, change the quality or any variable that they might care about. So this might be important information that you get from the firms, but exactly as for consumer surveys, and I'll go back to that, what you care about are marginal consumers. So when you change prices marginally, we are not talking here about withdrawing products from the market, we are just talking about increasing marginally the price, or by 5–10% the price of some products. You want to identify first those consumers who will switch from product A to something else, and on those consumers only compute diversion ratio. So look at where those consumers are switching. You don't necessarily care about having consumers who tell you that they might switch, that if product A is not available, so that's often what you will get on consumer surveys. If product A is not available, they will switch to B or C. What you want to know is whether they would first switch from A to something else, and then if yes, then whether they will go to B or C. And if those marginal consumers are not the same as the average consumers, then you might have some measurement issues there on your diversion ratios. But those are consumer surveys or evidence. You know that they might not be extremely precisely measured, but at least you have something that might be simple, that's better than market shares, and that help you to compute your price screens. So how do they perform? So I won't talk about Mark's paper, given that Mark will talk about that in a few minutes. So let me talk about one paper that looks at the performance of UPP screens based on real data from the America West US Airway merger. And so what that paper does is look at pre-merger data to anticipate the price effect. So what you would have computed as price effect using merger simulation in those cases based on the available data pre-merger, and then using the estimated demand, compute diversion ratios and compute UPP values for those mergers, and compare the result that you would have on using UPP test and using merger simulation. So don't know if you can see everything here, but let me just focus on a few things. So one is, so what it does is compare what market share screens would do compared to UPP first, and compared to anticipated price effects. So if you look at the last line in the table that you have on the right, so those are the markets that would be considered as being most likely to generate anti-competitive effects. So out of slightly over 100 markets, using just HHI values, you would identify 62 overlapping routes as being problematic in that merger. So this would give you a lot of work at starting looking at route by route where there is actually a strong risk of anti-competitive effects, when using merger simulation would restrict that to only 18 routes being problematic. And UPP does something in between. If we look at the scatter plot on the left, you see that what we would like, so if UPP was to be extremely efficient, we would like to see points only in the top right and in the bottom left corners. So situations where the anticipated price change or simulated price change has the same sign as what UPP would predict. Well, in the end, it doesn't work that, it's not that bad. Also, you have, obviously, you make some mistakes. You have some routes that would appear in the top left or bottom right corners. But overall, the correlation between UPP and price simulation is not too bad, and it's much better than what you would do with market share screens. And Mark will go further on that, so I won't insist too much. So how much I do? 5 minutes. Okay, so merger simulation. So merger simulation, as Joe explained, is you use the available data, you estimate your demand model. Based on that, you use information, you use your assumptions on how the competition takes place in the market pre-merger to get information on either to recover the marginal costs or to choose your right demand model if you already have information on the marginal cost. And then you use your estimated demand and cost function to re-simulate what the new equilibrium will be post-merger. So it makes a lot of assumptions potentially on what the demand functional form or cost function will be, but it also allows you to do a lot of things like not only looking at what the price effect will be, but adding long-term variables. You can allow firms to reposition products or to withdraw products, which is not necessarily easy with other screens. And it also allows you to look at consumer surplus overall. One of the difficulties is when you have, if you have efficiency gains in those models, what might happen is once you simulate your equilibrium, your new post-merger equilibrium, some of the prices will have gone up, some of the prices will have gone down. So how do you combine all those price increase and price decreases in one simple way to know whether your merger has anti-competitive effects or not? Well, at least if you've, it's true that you put a lot of functional forms in your model, but that also allows you to compute consumer surplus and aggregate in a meaningful way all that information. So can we compare the efficiency of price pressure screen and merger simulations? Well, yes, Mark will do that, or partly do that in his presentation, but we should also remember that those are two very different instruments. One is meant to be a screen that helps you to decide whether to spend more or less time on a merger. So you want to be able to do that pretty quickly with little information, and it's not predicting the full outcome of the merger. Doing merger simulation might be possible in some cases, even in phase one, but in many cases, this is something that will rather take time and that you only have time to do once you've decided to open a phase two investigation. And it's also pretty costly to gather the data, spend the time to do the merger simulation, so you might not want to do that on all mergers simply to decide whether to screen them or not, so whether to go to phase two or not. So the choice, so as Joe explained, you put a lot of structure on the functional forms of your demands when you do merger simulation, and that will have an impact on the estimated price increase that the merger will generate. So here I've put a table from a recent paper by GRIGOLON and VERBOVEN who look at, so that part of a paper looks at data, so true data from the car industry in Europe. So they use the available data to estimate a demand model using different types of demand models that are commonly used. So the logit, nested logit, random coefficient, and random coefficient nested logit. They estimate the demand parameters for these 4 different forms of demand functions, and from that they simulate the new equilibrium for some possible mergers in that industry and look at the price effect of that merger. So I've just put one here. So they look at the potential effect of a merger between Peugeot, so Peugeot, Citroën, and Renault on the French market using the available data, and they look at the, so on the table, on this red square here on the left, you have the simulated price effect of the merger overall, so average price increase following the merger depending on the model you estimate. And as you can see, there are very strong differences depending on the model that you are using to estimate your your price effect. So it could go from 1% to 20% overall, depending on whether you use a simple logit model or whether you use a random coefficients logit model. So really the choice, the model you will choose, you need to be sure you've chosen the right model before you can really think you've predicted quite accurately the price increase of your merger. So it doesn't mean that you shouldn't carry out merger simulation when you have the right data, but you need to do it carefully to make sure that what you are simulating is something that's really meaningful. So if you choose the wrong demand model, you know that you will get something that might be very far off the mark, and you might make big mistakes. So there have been other papers looking at merger simulation and doing that through ex post evaluation of implemented mergers. There's one case in the breakfast cereals where Aviv Nevo had looked in his paper on simulating potential mergers and look at the potential effects, or the effect of a simulated effect of some potential mergers. One of those mergers took place, and Aschenfeldt and Hosken looked at the true impact of that merger on the market. When you compare the two, on average, the simulation did a relatively good job for major brands. The anticipated price increase was about 2%. The actual price increase was about 3%. If you start looking brand by brand, then you start having more differences. And Peters also looked at mergers in the airline industry, looking at the predicted price change, using, again, different demand models and comparing that to the observed relative price change. Here you can see more differences. So if you look at some of those lines, you see the nested logit would usually generate much lower price increases than the true observed price change. But what we should remember is that merger simulation is only predicting the effect here on one variable. So you're only changing price, keeping everything else constant. So the routes, the number, the frequency of your flights, and so on. Here you might have, in the actual effect, you might observe more than just changing your price variable, which can explain also why merger simulation might seem imperfect in that case. Can I just go back? And just to conclude, is one thing that we should remember, and merger simulations, or those UPP or screens, have often been used in mergers using scanner data for products that are readily available in supermarkets when the merger took place at the upstream level, so between manufacturers. And so what the models are doing in those cases is really estimating diversion ratios or simulating price effects, assuming in a sense that that industry is totally integrated or completely abstracting from vertical relations between the supermarkets and the manufacturers. And if the mergers at one level can have an impact on the margins, on the way margins can be shared between the parties, that might have a strong impact as well on your merger simulation and on how imperfect your results will be. So it's a very still imperfect issue. We need more robust theory to predict or to allow merger simulation to integrate those vertical integrations in a simpler way. It might not always be feasible in a very short time frame that merger control, in which the merger control takes place, but we need to make the model as precise as possible if we want the merger simulation to be effective and not suffer from the same difficulties that we might have with other screens. And I think I'll stop there.
Thank you.